Welcome back. Today we're going to continue talking about section 5.2, solving by factoring. One method that I did not show you guys in the last video, but we did kind of use it a little bit. One thing you can always check for first is if you have it's called the GCF, greatest common factor, which is what we were looking for when we used that AC method, and we were looking for what would divide the biggest number or expression that would divide into both of those. So if I look at 5x squared minus 20, well, I notice right away that both of those can be divided by 5. So I take the 5 out. It doesn't just go away. And I divide 5x squared by 5. I'm just left with x squared, and minus 20 divided by 5 is 4. And lucky for us, a little refresher here. X squared is a perfect square. 4 is a perfect square. We've got a subtraction sign in between them. So we end up with 5 times x plus 2 times x minus 2. Remember, x's are the square root of x squared. 2 is the square root of 4. Opposite signs in the middle. So sometimes you can break them down farther, sometimes you can't. If we go look at B, I look at those and I look at 6, 15, and 9, and I go, seems like something should be able to divide all of those. Well, wait, 3 divides 6, 3 divides 15, and 3 divides 9. So I take my 3 out front, and 6p squared divided by 3 is going to leave me with 2p squared, plus 15p squared is going to be 5p, and plus 3. And just for fun, let's take a look and see if we can factor this using our guess and check method. So I keep my 3 out here. I know I'm going to need 2 sets of parentheses. To get 2p, or 2p squared, I need to multiply 2p and p. And I look at my signs. I've got addition, so I know they're the same. I look forward. That is an addition sign. So I'm adding in both of these, and I need factors of 3. Well, I need to get to 5. So the only factors of 3 there are 1 and 3. So I'm going to put my 3 here and my 1 here. If I check that, 3 times p is going to give me 3p plus 2p going on the outsides. Hey, that's 5p. We're in good shape. Then, looking at problem C. What can I take out of both 2u squared and 8u? Well, I look at 2 and 8, and I say, well, 2 is going to divide both of those, of course, both even numbers. But I have a u squared and a u. So just like yesterday, we can take an extra u out of that. And I'm left with 2u squared divided by u is going to leave me with a u. Plus 8u divided by 2u. Well, the u's will cancel out. 8 divided by 2 is 4. And if I were to distribute the 2u back in here, of course, I would get 2u squared plus 8u. But you don't need to. This is where you stop. So from there, you know, these first ones, sometimes they both broke down after we took out this greatest common factor. In our last one here, we're going to take a look at 4x squared plus 4x minus 4. Well, hopefully it's obvious that you can take a 4 out of there, so you're left with x squared plus x minus 1. Big mistake here is forgetting to leave a 1 there. A lot of people just want to leave it as x squared plus x minus and x squared plus x and think that 4 is magically going to get at the end there. So double check yourself. Negative 4 divided by 4 is negative 1. So keep that in your expression. Now, if I try and factor this, this is one of the ones where the number in front of x squared is 1, so this makes it nicer for us. I see a negative back here. That's going to mean opposite signs for me. And I need factors of 1 that add up to positive 1. Well, if I put a 1 and a 1 here, because that's the only thing that's going to multiply to 1, then I'm going to get plus x minus x. Well, that doesn't give me x. It gives me 0. So not all of these break down after your greatest common factor is out of there. And I can show you how to, I'll show you how to deal with those later. But this right here, this 4 times x squared plus x minus 1, that is going to be as far as we can break that one down. So if you get to the point where you can't break it down anymore, can't factor anything else out, I know we could in A and B, but looking down here at D, we can't do that on every one. Then, today, the whole key to what we are going to do today is based on the fact that we're dealing with the zero product property. So, the zero product property says that if you multiply two numbers or algebraic expressions, whatever they are, if those two, A and B, multiply to 0, then either A equals 0 or B equals 0, or both of them equal 0. But in order to multiply to 0, something has to be 0. Nothing multiplies to 0 unless it's being multiplied by 0. So we're going to use that to help us out today. So if we look at 2x squared plus 3x minus 18 is equal to 0, we need to make sure that this right side is equal to 0. From there, we need to factor the expression on the left. So I am going to factor this. I'm going to use my guess and check what multiplies to x squared, x, and x. I look here, I've got opposite signs, 1 plus, 1 minus. I need factors of 18 that add up to 3. Well, I've got off to the side here, I've got 1 and 18. I've got 2 and 9. I've got 3 and 6. And I think that's all we got. So I need a certain combination of these to add up to 3. So if I take positive 1 minus 18, nope. Positive 18 minus 1, nope. Positive 2 minus 9, nope. Positive 9 minus 2. Closer, it gives me 7, but not 3. If I do positive 3 minus 6, that gives me a negative 3. But if I do 6, positive 6 minus 3, there's my winner. I need a positive 6 minus 3. And there's how that's going to factor out. Now, the key to the zero product property, this is going to allow us to take each one of these binomials and set them equal to 0. X plus 6, x minus 3. Equal to 0, equal to 0. We can solve these. So I subtract 6 from both sides over here. I get x is equal to negative 6. I add 3 to both sides over here. I get that x is equal to 3. And now I have a lot of people normally at this point go, well, which one's the answer? Well, they both are. Okay? What we're looking for is where this graph crosses the x-axis. Looking for those x-intercepts. Here's where they are. So since we've got that U-shaped graph, we're going to end up with 2 answers. The next one, first thing we got to check, is it equal to 0? Nope, it's not. Our right side is equal to 3t minus 5. So I'm going to subtract 3t from both sides. So I end up with 2t squared minus 20t plus 45 is equal to negative 5. Add my 5 over. I get that 2t squared minus 20 t plus 50 is equal to 0. Now we can start looking to factor. Now, before you just jump in here, look at your numbers. 2, negative 20, and 50. Do I have a greatest common factor? I do. I can factor out that 2, so I'm left with t squared minus 10t plus 25 is equal to 0. This is a little easier for us to factor. Now I go through my same factoring process. I keep my 2 out here, set my 2 sets of parentheses, t and t multiply to t squared. I have same signs, look ahead, what are they? Both subtraction. And what multiplies to 25 and adds to 10? Well, since they're both the same, 5 and 5 multiply to 25 and multiply to 10. And now, normally we'd set each of these equal to 0. But since they're the same thing, I can just set one of them equal to 0 and solve. Add 5 to both sides. T is going to be equal to 5. A lot of people ask me, do you need to worry about this too? Nope. If you really want to, you can divide it over here. Divide this left side by 2, right side by 2. It won't change anything. Or if you don't like that, you can just ignore it and not worry about it for right now. It doesn't have a lot of meaning to us. So what you're just worried about is the numbers inside the parentheses, setting those equal to 0. One last way, I can give you questions to do the same thing, is find the zeros. So it's identically the same process. It is the same type of work. The only difference is I'm going to give you a function, y equals x squared minus x minus 6. Again, same idea. You need it equal to 0. So x squared minus x minus 6 is equal to 0. We can just set that y equal to 0. Factor, get my sets of parentheses, equal to 0. What multiplies to x squared? X and x. Opposite sign, since I have a negative in front of my 6, I'm going to go 1 plus, 1 minus, and factors of 6, 1 and 6, 2 and 3, and I need it to add to negative 1, so negative 3, positive 2, equal to 0. So I'm going to get x plus 2 is equal to 0, x minus 3 is equal to 0. Minus 2 from both sides, x equals negative 2. Add 3 to both sides, x equals 3. Remember, show me all your work on these. I know they're easy equations, but it's easy to make a mistake. So it's one of those little things that will help you out in the long run. Now, the question asks us to find the zeros. This means that we're looking at x-intercepts. Which means we write these as points. So we're going to get the points. Negative 2, 0, and 3, 0. So, same idea, just slightly different way of asking that. If you have questions, let me know. That's all I got for you today, and I will see you guys in class.